Hey everyone, this week is my finals week, so I decided that why not make a video about some of the stuff I've been studying. So, one of my classes is a class called Business Data Mining, in which we use a lot of machine learning techniques like close nearest neighbors, KNN, k-means, clustering, text mining, using stemming, stop word removal, so on and so forth. And one thing in particular that I wanted to kind of describe to you, and maybe it could help myself out in studying for this exam, is talk to you about one of these methods for this exam. So I'll be talking to you about k-means. Let's begin by saying, what is k-means? K-means is an unsupervised learning model that groups the unlabeled data into clusters or k-partitions. In essence, it means that unsupervised data is unlabeled and not into classes. Why do we use k-means? Well, in terms of machine learning, k-means is simple, i.e. you're just clustering and grouping data into clusters to find which clusters are similar and which clusters are dissimilar to other clusters. It's fast in the terms that it can handle large data sets relatively quickly to other machine learning algorithms. And it's cheap in that it doesn't use as much memory compared to other machine learning algorithms. One real-world example is web search results. Some measures we use to calculate distances between points. The most common one is Euclidean distance, which is the sum of the data points squared, all under the square root. And the Manhattan distance, which is the sum of the absolute value of the data points. So let's take this example where it says use k-means algorithm to classify. We have 8 data points in various locations. Use the Euclidean function with k equals 3. So there's 3 centroids in this case. So, and the initial centroids are given. 2, 10, 5, 8, 1, 2. So we have to figure out the Euclidean distance between each centroid and the data point. So since P1, P4, and P7 are centroids, the first and second, third centroid, those are 0. So for example, we used P1 to centroid 2. So P1 has the coordinates of 2, 10, and centroid 2 has the coordinates of 5, 8. So in order to calculate that, we have to do the square root of 5 minus 2 squared plus 10 minus 8 squared of the y's. So the 5 minus 2 is the x's of P4 and P1, 10 minus 8 is the y's of P4 and P1. And you square them. So it gives us the square root of 13, which is 3.605. So now that we see that the points aren't balanced, i.e. each centroid doesn't have the even amount of data points of the data set, we still have to do another iteration. So in order to do another iteration, we have to take new clusters. So 3 more clusters. The first one, since there was no data points, it was just the cluster itself. We still use 2, 10, but for C2 and C3, we take the average of the data points coordinates and divide it by the amount of data points in those clusters. So C2, as you can see, there's 5 data points. So we take the x's divided by 5, y's divided by 5, and come out with 6, 6. C3s, you get the same result, except there's only 2 data points. So in this case, the new center would be 1.5, 3.5. And again, once we go through the table and use the Euclidean distance, we still have an unbalanced grouping of clusters. So we still have to calculate new centroids. And as mentioned in the previous slide, it would show you the formulas to do that. You take the average. So since C1 now has points, the new centroid becomes 3 and 9.5. C2 becomes 6.5, 5.25. C3 remains the same as 1.5, 3.5. And once again, we still use a Euclidean distance, but now we have a balanced data set and our clustering is complete. So we have to do no more iterations in which our new centroids become 3.669, and 4.33, 1.5, and 3.5 remains the same. Those are the new centroids we use in calculating those Euclidean distances. And now we have a finished cluster. And now we don't have to do any more iteration. Now, in terms of selecting the best K for clustering of K-means of a given data set, if you want to experiment of a certain data set, we use the elbow method. So you calculate within groups of the sum of squares. You don't have to do it by hand. You can use R, Python, MATLAB, etc. They have these functions of K-mean. And what you have to do is when you graph this, you have to find the elbow point. Essence means basically when the graph starts to kind of tail and curve out a little bit. So as you can see, the elbow point here is 4, which means that 4 is the optimal usage of K in this example. I hope you learned a thing or two about K-means as being tested on it, so hopefully I said the right things. I feel pretty confident I did, but I feel pretty confident going into this test. So wish me luck.